Hello everyone, I am going to talk about the tree problem today, and it was quite a shocker 2 years ago when the first time students saw it. So let's see, use the data. So this is a typical one, is the Riemann. Usually you need to find a derivative and an integral using a table. So the derivative would be the slope. The integral would just, you have to specify, or they have to specify what kind of Riemann sum they want. And there is one here, trapezoidal. So that's a typical exercise, and you've seen this style before, okay? So that's the Riemann problem. So estimating h prime of 6. So h prime of 6, okay, usually they choose a point right here in the middle, and don't forget to do rise over run, not the other way around. So it would be 11 minus 6 divided by 7 minus 5. This is called the difference quotient, and you need to show that in your work for the College Board, okay? And then what are the units? Well, you take the units on the top, and then you take the units on the bottom, so you get meters per years. Okay, and what is this? Is the rate of change of the height of the tree and it's important to specify at t equals 6, as it's not everywhere. Okay, so I'm going to highlight that at t equals 6. Okay, so highlighting the units, don't forget, don't forget to, meters per year. Okay, let me put that again. Meters per year. Okay. So don't forget to put the units. The format is the difference quotient. So that might be 2 or 3 points. Just look at the scoring rubric for today. Okay. Part B. So that was part A. Part B. When would a derivative equal to a number? Okay. So we have two major results. A function is equal to a number. You're going to use IVT. And a derivative equals to a number. Then you're going to use MVT. Yes, MVT, IVT kind of go into mixed types of problems, and no AP problem is clean cut. This is just the Riemann in the table, and the next one is just the area in FTC, or just the rate in, rate out. So obviously there are topics that are intermixed, and that's the foundation of a cumulative exam like the one that you're taking. Okay, so part B in here. Okay, so why there must be a time between 2 and 10 such that the derivative equals to 2. So you might be, because they gave you the time span 2 to 10, you might be tempted to find a derivative there, and bummer, that's not going to give you 2, because you kind of have 13.5 divided by 8 in here. So that's not quite 2. So how are we going to handle that? Well, we need to find a specific interval where that occurs. When would the rate of change be about 2? Well, from 2 to 3, no, that's not 2. From 3 to 5, that's like 4 over 2. Okay, so you are going to say capital H is continuous on 3 to 5 closed. Okay, so we're going to lay out the conditions of MDT. Differentiable on 3 to 5 open, and by NVT, there is a C inside the interval 3 to 5 such that ST, that's my shorthand for such that, H prime of C is equal to H of 5 minus H of 3 divided by 5 minus 3, which indeed is equal to 2. This is called the difference quotient. So be real careful. You must have this piece in your argument, this piece, and this piece. So identifying the interval is not enough, and then obviously calculate it here. It's not enough to just kind of notice it, even though it seems like an obvious computation, to go in from 3 to 5 and see, oh, well, that's where the derivative is going to be 2, or the slope is going to be 2. It's not that obvious to do that directly. You need to specify the interval. Trapezoidal sum. Okay, so that's part C. Let me see how much space I have. Okay, so the average height of the tree. So this year they took off the average rate. But, so then you don't have to do, the average height is going to be 1 over 10 minus 2, and then you are going to build the trapezoidal sum. So this year you're probably only going to be here, and you're not going to have to deal with the average value. But this is the average value, okay? So let's put the trapezoidal sum. Notice how this values in the table are not equally spaced, so this is going to be the heights of your trapezoid, so essentially 1, 2, 2, and 3. Okay, so I'll just put it, don't be shy to multiply by 1. Okay, and then each time you're going to have the base 1 plus base 2 times height divided by 2, and base 1 plus base 2 times 10. So I put the heights in the division by 2, and now I'm going to put the values. So 1.5 plus 2, 2 plus 6. No need to simplify. And it's actually discouraged. Some people, when I was grading, because I graded this problem on the AP, when I was grading this problem on the AP, some people felt redundant to just show the multiplication by 1. You must show that, okay? You must show where your answer comes from. They're less concerned with the actual value at the end and more concerned where the answers come from. So 1.5 plus 2, 2 plus 6, okay, 6 plus 11 in here. And what else do we have? 11 plus 15. Okay, so that is the average value, okay? And then part D is interesting. That's a product rule combined with the related rate. So you have the height of the tree given by this, so it's in function of x, but x changes with time. This quantity in here is telling you that dx over dt, or x prime, if you want to be a little sloppy with notation, is equal to 0.03. So what is the rate of change of the height of the tree? So that means you need to find this g prime with respect to time. So you can find it first with respect to x, but because you're taking the derivative with respect to time, it's kind of a related rate. Anytime you take the derivative of x, it's going to be x prime. So dg over dt. It's best to write the variables, because if you're taking the derivative with respect to x, you're just going to do quotient rule, but because you're taking the derivative with respect to t, it's a little different. So the derivative at the top is 100 x prime, or dx over dt, okay, times 1 plus x, minus, leave the 100x alone, times, and I need to separate the work for these two parts, let's see, x prime, or dx over dt, yes? So divided by 1 plus x squared. So now you have what dx over dt is equal to. You have the tree is 50 meters per tall, so you're going to change x to be 50 and make dx over dt to be 0.03, and you plug that in and don't simplify, okay? I'm not finishing that. But this is a pretty cool problem. With the exception of the average height, which they might just say estimate using a trapezoidal sum, I suppose, the integral from 2 to 10. That's the only thing that I would change, and then it makes it a perfectly reasonable problem for this year, okay? Let's look at the second one. Another tree problem. Yes, this was 2017, I believe. Yes, so that's they're really fond of them, huh? So what else they're doing? Left the Riemann sum to approximate the volume in the tank. Okay, so when you integrate in the area, you get volume, right? Because the area times the x is a tiny cylinder, and the symbol for integration just means that you're adding tiny cylinders, so therefore you're going to get the whole volume. Okay, and indicates units of measure. So left Riemann sum is the integral between 0 and 10 of a of h dh, and it can be approximated by, okay, so we're going to pick off all the left values, and then we're going to multiply by the corresponding height. So 2 times 50.3 plus 3 times 14.4 plus 5 times 6.5, and that's about it. And what are the units? Well, what's volume measured on? Cubic feet, yes? Okay. Does the approximation overestimate or underestimate? Well, let's see. What do we know? That it decreases. So if A is decreases in part B in here, and you want to do the left Riemann sum, or all the left values are going to be above. So it's going to be an overestimate because A of H is decreasing. Okay, you might want to write that in Word, but yeah. Okay, and then some of this other stuff in here, it's optional, so we're not doing volume this year, but if you want to know, Okay, the volume in the tank. So volume is always the integral of the area of the cross section. So the volume, okay, and where are we going from 0 to 50? The area is given by this function, so 50.3 e to the 0.2 h plus h dh, and this was a calculator question, so essentially you just put that in your graphing calculator and that's it. And then part D, when what they're saying is take the derivative of this. Actually, in general, let me go back to part C. If you want this for any a height, then I'm going to go from 0 to h, where h is a number less than 50, and then I have to change some of the variables in here. This would be a d x maybe. So I'm going to change all the x's into t. I mean all the h's into x. Okay, so I don't have h going amongst itself. Okay, and then the other one in here is asking you what's dv over dh. So that's like fundamental theorem of calculus part 2. So what happens if you take the derivative of the integral? You just plug it in. So 50.3 over e to the 0.2 h plus h, and then times h prime, right? Because it's saying h prime is that. That would be h prime, or dh over dt. So times 0.26. Okay, so that's your h prime in here. Okay, and then plug in h to be 5 into this and carry out the computation from here on. Okay, thank you. I hopefully it makes sense. Otherwise, just ask me in the Zoom session or later on.